We rely on AI for so much these days, driving our cars, filtering spam, even helping doctors. But what if I told you these incredibly smart systems have a secret weakness, a blind spot that can be tricked in some really, really simple ways? Well, today we're going to dive deep into the fascinating and, yeah, kind of scary world of adversarial machine learning.
And this isn't some sci-fi movie plot. This actually happened. Researchers at McAfee figured out how to fool a Tesla. And get this, all they did was add a 2-inch strip of black tape to a speed limit sign. A tiny piece of tape. That was enough to make the car's AI misread a 35-mile-per-hour sign as 85. It's a wild example, but it perfectly sets the stage for what we're talking about today. AI can be fooled.
So you might be thinking that Tesla thing was just a one-off, a weird glitch, right? Nope, not at all. It's a perfect real-world example of a fundamental weakness that folks in the field have been studying for a while now. The thing is, the way machines see the world is just different from how our brains work. And it's that difference that attackers can exploit.
And believe me, it gets even weirder. I mean, look at this stuff. Researchers 3D printed a turtle that Google's AI thinks is a rifle from every single angle. A rifle. Others prove you can completely fool a deep learning system by changing just one single pixel in a picture. And then you've got companies making actual clothing, stealth streetwear, with special patterns designed to make you invisible to facial recognition cameras. It's wild.
Okay, so all these crazy examples have a name. It's a whole field of study called adversarial machine learning. You can think of it as the intersection of AI and cybersecurity. It's this constant cat and mouse game, a battle between the people trying to trick AI and the people trying to build stronger, smarter defenses. But how? How do they actually do it? I mean, we think of these AI systems as these super powerful, almost all-knowing brains. How can they be fooled by a piece of tape or a single pixel? Well, it turns out attackers have a playbook, and their methods are way more systematic than you might think.
All right, so let's pop the hood and look at this attacker's playbook. It really boils down to two main strategies, and the key difference between them is all about timing. Do you mess with the AI while it's still in school, or do you try to trick it after it's already graduated?
And this distinction is absolutely key. So first up, you've got data poisoning. This is like contaminating the water supply while the AI is still learning. You sneak bad data into its training set, basically corrupting its education from the very beginning. Then, on the other side, you have evasion. This is for an AI that's already fully trained and out in the world. It's like using camouflage to trick it in real time.
So let's talk about data poisoning. It can be super sneaky. For example, an attacker could feed a security system bad data, so it learns to ignore a specific kind of virus. Or think about social media. Bots and fake accounts can be used to poison the well, pushing recommendation algorithms to favor certain content. There's even this tool for artists called Nightshade. They can use it to poison their own images online, so if an AI model scrapes their art without permission, it learns all the wrong things. Pretty clever, right?
And that brings us right back to where we started. The Tesla. That little piece of tape on the speed limit sign, that was a classic evasion attack. The car's AI was already fully trained, but the attackers presented it with a modified input, the tweaked sign, that made it mess up. The AI wasn't broken or reprogrammed, it was just tricked right there in the moment. Okay, so we've talked about when an attacker might strike, but there's another big variable. How much do they actually know about the AI they're trying to fool? This leads to a whole other way of classifying these attacks.
This is where we get into white box versus black box attacks. Think of a white box attack like a heist where the thief has the full blueprints to the building. They know everything about the AI model, the architecture, the code, the data it was trained on. This lets them craft incredibly precise, powerful attacks. A black box attack, on the other hand, is like trying to crack a safe without knowing what's inside. The attacker has no idea how the AI works. All they can do is poke and prod it, feed it inputs, see what outputs they get, and try to reverse engineer its weaknesses. And of course, for each of these, there are specific named techniques that researchers have come up with. In the white box world, you have methods with names like FGSM or CNW. These are like surgical tools, using that inside knowledge to calculate the perfect, tiny change needed to cause a misclassification. Then, in the black box corner, you have things like the square attack or hop, skip, jump. These are more like clever interrogation techniques, systematically questioning the model to find a crack in its armor, all without seeing the code.
So what you have here is a classic digital arms race. Every time attackers figure out a new way to fool an AI, defenders have to rush to build a countermeasure. It's this constant back and forth that forces us to ask a really important question. Are we just building AI that's smart, or are we building AI that's actually secure and robust?
So how do the good guys fight back? Well, they don't just wait to be attacked. They use a proactive defense cycle. It's a continuous loop. First, they do what's called threat modeling. They try to think like the attacker. What are their goals? What are their capabilities? Second, they actually simulate those attacks to see where the weaknesses are. And third, they use that knowledge to design and build better defenses. Then, they start the whole cycle over again.
And this cycle has produced a whole toolbox of defense mechanisms. One of the coolest is called adversarial training. It's basically like giving your AI a vaccine. You intentionally show it a bunch of these tricky, hostile examples during training so it learns how to spot them and not be fooled. Other defenses focus on cleaning up the training data to get rid of any potential poison, or building special algorithms that are secure even if some of the computers they're learning from have been compromised.
Okay, this is all really interesting technical stuff, for sure. But let's bring it back home. Why does any of this actually matter to you?
Well, the thing is, AI isn't just in labs anymore. It's everywhere. And that means its weaknesses are our weaknesses. We're talking about the safety of autonomous cars on our roads, the security of the biometric systems like face unlock on our phones, the integrity of our information, from spam filters to spotting disinformation, and of course our privacy in an age of widespread facial recognition. This isn't just an academic problem anymore, it's a huge societal issue.
Now, the good news here is that the big players in tech are taking this really seriously. You've got companies like Google, Microsoft, and IBM. And they're not just keeping their defenses secret, they're actually creating open-source toolboxes that anyone can use. This means researchers, startups, anyone building AI can test their systems, find these vulnerabilities, and work together to make AI more robust for all of us.
And all of this leaves us with a really big, lingering question to think about. As AI gets more and more powerful and woven deeper into the fabric of our lives, will we even be able to tell when it's being deceived? Building AI that we can truly trust isn't just about making it smarter. It's about making it wise enough to know when it's being fed a lie.